Greetings and welcome once again. I am your host, Harshit Sinha, and I shall now continue from where we left off in my previous day's presentation, delving further into the remaining aspects of the E-Waste Management Rules, 2022. In today's discussion, I will elaborate on the global context of E-Waste governance, the various categories of E-Waste, and the specific provisions made for specialized and imported equipment. Furthermore, I will outline the roles and responsibilities of producers and local governing bodies. The presentation will also encompass an overview of established standards, verification and audit mechanisms, and the enforcement framework that ensures regulatory compliance. Lastly, I shall address the prevailing challenges in implementing effective e-waste management practices and explore the emerging opportunities in this crucial domain. This comprehensive overview aims to provide a deeper understanding of the multifaceted regulatory structure governing e-waste management in India and beyond. Slide 2. Global context of e-waste management. The global context of e-waste management highlights a pressing environmental challenge, with worldwide e-waste generation reaching approximately 53.6 million tons annually. Asia accounts for the largest share, followed by the Americas and Europe, while Africa and Oceania contribute comparatively less. In response to this escalating issue, many nations have introduced comprehensive regulatory frameworks to manage e-waste more effectively. India's e-waste management rules, 2022, align the country with global best practices, incorporating elements found in successful systems worldwide. These include extended producer responsibility, EPR, mandatory reporting, standards for safe handling and recycling, and restrictions on hazardous substances. Such measures aim to ensure environmentally sound management and minimize health risks. By adopting these proactive approaches, countries position themselves to combat the adverse impacts of unchecked e-waste, promote circular economy principles, and encourage sustainable electronic consumption and production practices globally. Slide 3. Categories of electrical and electronic equipment. The E-Waste Management Rules categorize electrical and electronic equipment, AE, into 7 primary categories, as outlined in Schedule 1 of the 2022 regulations. These categories reflect the diverse range of electronic products contributing to e-waste. The first category includes information technology and telecommunication equipment, such as computers, mobile phones, and networking devices. The second category covers consumer electricals and electronics, including items like televisions, radios, and photovoltaic panels. The third category encompasses large and small electrical appliances, ranging from refrigerators and washing machines to electric kettles. The fourth category involves electrical and electronic tools used for maintenance or operations. The fifth includes toys, leisure, and sports equipment. Medical devices, both for diagnostic and therapeutic purposes, form the sixth category. Lastly, the seventh category consists of laboratory instruments used in scientific and educational settings. This classification system ensures targeted and efficient e-waste management by addressing the specific disposal and recycling needs of each category. Slide 4. IT and telecommunication equipment. The category of IT and telecommunication equipment under the E-Waste Management Rules comprises a wide range of electronic devices essential for information processing and communication. Computing devices form the core of this category and include mainframes, microcomputers, laptops, tablets, notebooks, and desktops. These are major contributors to e-waste due to their rapid obsolescence driven by continuous technological upgrades. Printing and copying equipment, such as printers, including cartridges, scanners, copiers, and electronic typewriters, also fall within this classification. These devices typically have shorter life cycles but contain valuable recoverable materials. Communication devices encompass a variety of tools including telephones, payphones, cordless phones, answering systems, mobile phones, fax machines, and routers. Additionally, base transceiver stations, excluding tower structures, used in telecommunications are part of this group. These items are crucial for modern connectivity but generate significant e-waste, underscoring the need for their responsible disposal and recycling under the outlined regulatory framework. Slide 5. Consumer electronics and photovoltaics. The category of consumer electronics and photovoltaics under the E-Waste Management Rules includes a broad range of household and energy-related equipment. Display devices, such as televisions, LCD and LED, electronic photo frames, monitors, and electronic display panels fall under this group. These devices often contain valuable yet hazardous components that require specialized handling. Major appliances like refrigerators, washing machines, and air conditioners, including centralized systems, are also included. These items, due to their large size and extensive use, contribute significantly to e-waste and often contain recyclable metals and other valuable materials. Additionally, photovoltaic equipment, including solar panels, cells, and modules, is recognized as a vital part of this category. As the adoption of solar technology increases, the need for end-of-life management of these systems becomes crucial. This classification ensures that these widely used devices are managed responsibly through appropriate recycling and disposal processes to minimize environmental harm. Slide 6. Large and small electrical equipment. The category of large and small electrical equipment covers a broad spectrum of household and commercial appliances that contribute significantly to e-waste generation. Large electrical equipment includes items such as cooling appliances, freezers, dishwashers, clothes dryers, cooking equipment, heating appliances, and ventilation systems. These appliances are commonly found in households and industries and often contain valuable metals, plastics, and sometimes hazardous substances, making their responsible disposal essential. Small electrical equipment consist of vacuum cleaners, irons, sewing machines, coffee makers, carpet sweepers, electric shavers, hair dryers, kettles, and similar portable devices. While individually smaller, these items are used extensively and replaced frequently, leading to a cumulative impact on e-waste volumes. This category underscores the importance of systematic collection, recycling, and recovery processes to ensure that both large and small devices are managed in an environmentally sound manner, minimizing their ecological footprint and maximizing material recovery for reuse. Slide 7. Medical and laboratory equipment. The medical and laboratory equipment category under the e-waste management rules includes specialized electronic devices used in healthcare and research, which require careful end-of-life handling due to their complexity and potential hazards. Medical imaging equipment such as MRI machines, PET scanners, CT scanners, and ultrasound systems, including their accessories, are part of this group. These devices are essential for diagnostic purposes and contain valuable as well as sensitive components. Treatment equipment includes devices used in cardiology, radiotherapy, dialysis, pulmonary care, and nuclear medicine, among others. These appliances are crucial for treating, monitoring, and managing various medical conditions. Laboratory instruments comprise tools used for in vitro diagnostics, analysis, and experimentation, such as gas analyzers and spectrometers, commonly found in clinical and research laboratories. Due to their critical functions and intricate designs, the proper disposal and recycling of these instruments are necessary to prevent environmental harm and recover valuable materials. Slide 8. Hazardous substances exemptions. The hazardous substances exemptions under Schedule 2 of the e-waste management rules provide clearly defined allowances for the use of certain restricted substances in specific applications where safer alternatives are not yet technically or economically feasible. These exemptions are accompanied by strict maximum concentration limits to ensure environmental and human health safety. Mercury in lamps is permitted in various fluorescent lighting types, with specific limits based on wattage and lamp design. For instance, compact fluorescent lamps used for general lighting under 30 W may contain up to 2.5 mg of mercury. Lead in alloys is exempted when used as an alloying element in materials such as steel, up to 0.35%. Aluminum, up to 0.4%, and copper, up to 4%, where it serves important functional purposes. Lead in electronics is allowed in high-temperature solder, ceramic components, and specialized glass where alternative materials are not practical due to technical constraints. Other exemptions include substances like cadmium, hexavalent chromium, and specific flame retardants in critical applications where they are essential for ensuring reliability, performance, or safety. These exemptions are necessary to balance innovation and environmental protection, ensuring continued function in key industries while gradually moving towards safer alternatives. Slide 9. E-waste recycling targets and special provision for new products. The E-waste management rules establish progressive recycling targets for producers, aiming to ensure responsible end-of-life management of electrical and electronic equipment. As per Schedule 3 of the rules, the recycling target is calculated as a percentage of the quantity of products sold in the market in the year X, where X refers to the base year. These targets are set to increase gradually over time, beginning at 60% for the years 2023-2024, rising to 70% for 2025 to 2027, and eventually reaching 80% from 2027-2028 onwards. This phased approach promotes steady enhancement of recycling infrastructure and compliance readiness among stakeholders. Additionally, Schedule 9 provides special provisions for new producers who have recently entered the market. For such producers, the recycling obligation is based on their initial years of operation. In 2023-2024, the target is 15% of the average sales figure from their first 2 years. This increases to 20% in 2024-2025, and further to 25% in the subsequent years. Once the number of operational years equals the average lifespan of their product category, the producer's obligation aligns with the standard Schedule 3 targets. These measures aim to encourage early compliance while supporting new entrants in building sustainable business practices. Slide 10. Specialized equipment categories and imported equipment requirement. The E-waste management rules recognize specialized equipment categories to ensure comprehensive coverage of E-waste sources. Under this classification, electrical and electronic tools include devices like drills, saws, sewing machines, sanders, grinders, and equipment for cutting, welding, soldering, and similar industrial uses. These tools often contain reusable motors and valuable components that can be extracted during recycling. The toys, leisure, and sports equipment category covers electronic toys, video game consoles, sports gadgets like electric scooters and ride-ons, and gym equipment. As technology becomes more integrated into consumer products, this category represents a growing source of E-waste and requires responsible handling and recycling mechanisms. Regarding imported equipment requirements, the rules impose a strict 100% extended producer responsibility (EPR) on importers of used electrical and electronic equipment. Whether the equipment is new or second-hand, importers must ensure full compliance with recycling obligations. This is critical to prevent India from becoming a dumping ground for E-waste. Import compliance is regulated under the Indian Ports Act, 1908, and the Customs Act, 1962. Port authorities and customs officials play a key role in enforcing these regulations. The Central Pollution Control Board, CPCB, must be informed of any irregular imports, ensuring adherence to environmental safety standards. Slide 11. Solar Photovoltaic Waste Management. The solar photovoltaic (PV) waste management provisions under the E-waste management rules are tailored to address the specific characteristics and end-of-life challenges associated with solar PV modules, panels, and cells. Given the rising adoption of solar energy in India, the rules include special provisions to ensure responsible management of PV waste. One key aspect is the extended storage period, allowing manufacturers and producers to store solar photovoltaic waste generated up to the year 2034-2035, as per CPCB guidelines. This extended timeline acknowledges the long operational life of solar components and provides adequate time for developing effective recycling solutions. Furthermore, reporting requirements mandate that annual returns be submitted to the CPCB for the period up to 2034-2035. These reports must include detailed inventory data, supporting future policy formulation and infrastructure planning for solar waste management. Importantly, target exemptions are granted, meaning that standard E-waste recycling targets do not apply to waste from solar modules, cells, and panels. This exemption accounts for their extended lifespan and the current limitations in recycling technologies. Overall, these provisions reflect a pragmatic and future-focused approach to managing solar PV waste while supporting India's transition to sustainable energy. Slide 12. Local bodies' responsibilities. The responsibilities of local bodies, both urban and rural, are central to effective E-waste management under India's regulatory framework. One of their primary roles is waste segregation. Local bodies must ensure that E-waste mixed with municipal solid waste (MSW) is properly segregated, collected, and routed to authorized recyclers or refurbishers to prevent environmental contamination and promote recycling. A critical aspect also involves managing orphan products, which are unbranded or obsolete electrical and electronic items with no clear producer responsibility. Local bodies must ensure that such waste is channeled to registered facilities for proper treatment. Infrastructure development is another key responsibility. Local bodies are expected to enable the establishment of systems for the collection, segregation, and disposal of waste within their jurisdiction. This includes setting up necessary logistical and operational frameworks to handle waste efficiently. Lastly, capacity building is crucial. Local bodies must organize regular training programs to build the skills and knowledge of their personnel in handling waste. These trainings aim to enhance the technical and administrative capabilities required to support a sustainable waste management system at the local level. Collectively, these responsibilities emphasize the pivotal role of local governance in ensuring safe, systematic, and environmentally sound waste disposal and management. Slide 13. Standards for refurbished products. The formulation of standards for refurbished products plays a vital role in promoting sustainable waste management and circular economy practices. The Bureau of Indian Standards (BIS) is responsible for developing and issuing standards for refurbished electronic products under the waste management rules. These standards are essential to ensure that refurbished products meet defined thresholds of quality, safety, and performance. By doing so, BIS helps build consumer trust in refurbished goods, encouraging their adoption and extending the useful life of electronic devices through refurbishment instead of disposal. In parallel, the Ministry of Electronics and Information Technology, MITY, in collaboration with BIS, is tasked with creating detailed guidelines for refurbishers. These guidelines are especially relevant to the compulsory registration scheme, which aims to ensure compliance with established norms. The requirements encompass safety, electromagnetic interference, and other technical parameters that are typically applicable to new electronic products. Together, BIS and MITY ensure that refurbished electronics are not only safe and reliable but also hold market value, making them a viable alternative to new products. These standards are integral to fostering a responsible refurbishment ecosystem, reducing environmental impact, and enabling the circular use of electronic resources. Slide 14. Verification and audit mechanisms. Verification and audit mechanisms are essential for ensuring compliance with the waste management rules and maintaining accountability across the waste value chain. The Central Pollution Control Board, CPCB, either directly or through designated agencies, conducts random inspections of various stakeholders such as producers, refurbishers, dismantlers, and recyclers. These inspections help detect non-compliance and reinforce regulatory oversight. In addition to random checks, periodic audits are conducted as deemed necessary to assess whether entities are adhering to the provisions of the rules. These audits are critical for evaluating performance and identifying gaps in implementation. Certificate verification forms another key element. Under the Extended Producer Responsibility (EPR) framework, certificates related to waste disposal or recycling must be verified by the CPCB or its authorized agencies to ensure their authenticity and accuracy. This step prevents fraudulent reporting and helps maintain the integrity of the system. Finally, enforcement actions are taken based on findings from inspections and audits. These may include penalties or legal actions in response to violations of the rules or failure to meet environmental compensation provisions. Together, these mechanisms ensure transparency, promote accountability, and drive better environmental outcomes in waste management. Slide 15. Worker safety and formalization. Worker safety and formalization are critical components of sustainable and equitable waste management. The Department of Labor in states and union territories, along with authorized government agencies, plays a central role in ensuring the recognition and registration of workers involved in the dismantling and recycling of waste. This process helps integrate workers from the informal sector into the regulated system, offering them greater security and dignity in their work. Through formal registration, workers gain legal identity and access to various benefits such as improved working conditions, social security coverage, and skill development opportunities. This not only enhances their safety and well-being but also supports the creation of a trained and reliable workforce for the waste sector. In parallel, group formation is encouraged by labor departments to support the establishment of worker collectives in dismantling and recycling units. These groups enhance bargaining power, promote fair labor practices, and open up new economic opportunities. To safeguard health and safety, annual monitoring is mandated to address occupational hazards arising from waste handling. This includes ensuring the use of protective equipment, adherence to safety standards, and mitigation of risks linked to toxic exposure. Overall, formalization fosters a more resilient, fair, and environmentally responsible waste ecosystem. Slide 16. Digital infrastructure for implementation. The digital infrastructure for implementation under the waste management rules is centered around a robust centralized online portal developed by the Central Pollution Control Board, CPCB. This digital platform serves as the backbone for executing various aspects of the waste regulatory framework, including registration, reporting, certificate trading, and compliance monitoring. The central portal is designed to be a comprehensive system that streamlines the implementation process. It supports real-time tracking of waste flows and the fulfillment of extended producer responsibility (EPR) obligations, reducing paperwork and enhancing efficiency. A key feature of this infrastructure is stakeholder integration, which enables seamless coordination between producers, recyclers, refurbishers, and regulators. By connecting all key players in one ecosystem, the platform enhances transparency, ensures data consistency, and improves accountability in waste management practices. Additionally, the portal supports certificate trading, which facilitates the exchange and verification of EPR certificates. This mechanism ensures that EPR obligations are met through credible transactions, promoting regulatory compliance. Overall, the digital system improves governance by simplifying processes, promoting traceability, and enabling timely interventions. It represents a significant step forward in building a transparent, efficient, and scalable waste management framework in India. Slide 17. Circular Economy Approach. The circular economy approach outlined in the waste management rules emphasizes sustainable product design, resource efficiency, and waste minimization through reuse and recycling. This approach encourages manufacturers to adopt design for recyclability, using technologies and methods that make electronic products easier to dismantle and recycle at the end of their life cycle. A key element is component compatibility, which ensures that components from different manufacturers can be reused or replaced more easily. This reduces dependency on entirely new products and enables efficient repair and upgrading. Another major pillar is the extended use of products through refurbishing. The rules promote refurbishment by providing incentives and support mechanisms, which help prolong the usable life of electronic devices, thereby reducing the volume of waste. The final stage in the cycle is material recovery, where valuable raw materials are extracted from discarded electronics for reuse in manufacturing. This reduces the need for virgin resources and contributes to environmental conservation. Together, these four strategies, recyclability, compatibility, refurbishing, and recovery, form the foundation of a circular economy. The waste rules support these principles through the EPR certificate system and refurbishing certificate provisions, fostering economic incentives and creating a more sustainable, resource-efficient electronic ecosystem in India. Slide 18. Transition from previous rules. The transition from the previous rules to the waste management rules 2022 marks a significant step in evolving India's regulatory framework for waste management. The new rules supersede the 2016 rules, building upon lessons learned and addressing new challenges that have emerged over time. While replacing the earlier framework, the 2022 rules ensure continuity and legal clarity by clearly stating that the supersession does not invalidate actions undertaken or omitted under the 2016 rules. This protects stakeholders from retrospective complications and maintains regulatory consistency. To ensure a smooth transition, the 2022 rules include a migration provision for producers operating under the 2016 regime. Producers with active extended producer responsibility (EPR) plans approved under the 2016 rules are allowed to migrate to the new system in accordance with procedures defined by the Central Pollution Control Board (CPCB) and the approval of the steering committee. This structured migration avoids disruptions and enables producers to comply with the updated framework without administrative or operational setbacks. Overall, this transition mechanism reflects a balanced approach, introducing more efficient and future-ready regulations while ensuring that stakeholders can adapt without destabilizing the existing e-waste management ecosystem. Slide 19. Enforcement mechanisms. The enforcement mechanisms under the e-waste management rules are grounded in the Environment Protection Act, 1986, providing a strong legal foundation for ensuring compliance. These mechanisms are designed to deter violations and enforce accountability across all stakeholders in the e-waste ecosystem. A key tool is the imposition of environmental compensation, which involves financial penalties levied for non-compliance with e-waste management obligations. This ensures that violators bear the economic cost of their environmental impact. In more severe cases, authorities can resort to registration revocation, either temporarily or permanently, effectively stripping violators of their operating rights. This acts as a strong deterrent for repeat or willful offenders. For the most serious violations, the framework allows for criminal prosecution under Section 15 of the Environment Protection Act. This includes legal action against those who provide false information, willfully violate directions, or repeatedly breach compliance requirements. Slide 20. Challenges in implementation and opportunities in e-waste management. Effective e-waste management is critical for environmental sustainability, yet its implementation in India faces several persistent challenges. A major issue is informal sector integration. A significant portion of e-waste is managed by the informal sector, often lacking environmental and occupational safety standards. Integrating these workers into the formal waste management system is essential but complicated, as it requires balancing livelihood protection with regulatory compliance. Another major hurdle is consumer awareness. Public understanding of the harmful impacts of improper e-waste disposal remains low. Many consumers continue to discard electronic waste through regular waste streams or informal channels due to a lack of knowledge or access to proper disposal methods. Enforcement capacity also poses a challenge. Despite regulations, enforcement is weak due to limited institutional resources, insufficient monitoring systems, and poor inter-agency coordination. This results in regulatory gaps and continued illegal handling of e-waste. In addition, collection infrastructure is underdeveloped. Efficient and geographically inclusive collection systems are lacking. This hinders proper segregation, transportation, and recycling of e-waste, especially across rural and semi-urban areas where access to collection points is limited. On the other hand, there are several promising opportunities in e-waste management. Resource recovery is a key area, as e-waste contains valuable metals such as gold, copper, and rare earth elements. Efficient recycling can reduce the need for virgin material extraction and generate economic value. Green employment is another opportunity. Formalization of the sector can generate green jobs in collection, dismantling, recycling, and refurbishment, supporting both environmental and economic goals. Lastly, technological innovation presents vast potential. Innovations in product design for recyclability, reverse logistics, and digital tracking of waste flows can improve transparency and efficiency in the system. With this, we conclude the session on e-waste management rules 2022, Part 2. In our next segment, scheduled for the upcoming week, we will delve into the e-waste management rules 2023 and 2024, focusing on the key amendments and their implications. These recent updates bring significant changes in definitions, timelines, and compliance mechanisms that are essential for all stakeholders to understand. Stay connected with us on this channel as we continue to explore the evolving regulatory landscape of e-waste in India. Until then, goodbye and see you next week.